Okay, second hypothesis test example. This one was motivated from my experience as an undergraduate. I am left-handed, and typically I went to a school that had big lecture halls, and you had to take your notes on a little palette that was sticking out of your desk, and it was either coming out of the left side or coming out of the right side. Now, most of them were coming out of the right side so that right-handed people could write easily, and there was a small number coming out of the left side for the left-handed people. Typically, there was about 10% of the desks were left-handed. So lecture hall has 10% left-handed desks. Now, I always showed up to class early enough that I was able to get one of the left-handed desks, but it was not unusual for them to run out. And some people had to reach across their body and take notes on the other side. So you might hypothesize that more than 10% of the students were left-handed, and 10% left-handed desks was not enough. So let's test that out. So we hypothesize that the percentage of left-handed students is not 10%. Now, this example was motivated by the suggestion that it was actually more than 10% because the left-handed desks run out, but actually it was always also true that sometimes if the room was full, a right-handed student would be forced to use a left-handed desk. So we're going to stick with the alternative hypothesis of not equal. So our null hypothesis is that the proportion of students who are left-handed is 10%. That's the number that whoever was putting together the lecture hall was using. Our alternative hypothesis is that that number is wrong. And we need a testing level, so we're going to test at the 5% level. Now, I should say that when I give you an exercise, usually I will tell you the setup here, like sort of like the past thing that you're going to base your null hypothesis on, and the testing level. And you are going to have to come up with the null and alternative hypothesis based on those words. So the question would usually be set up like this. Okay. And the null and alternative hypothesis would be part of your answer. So first, you have to tell me the null and alternative hypothesis, and then you have to run the hypothesis test to generate a p-value. Now, in order to run the hypothesis test and generate a p-value, you need to know the result of the experiment. So I might tell you that here. So 18, so in our experiment, so maybe just one day we count how many students there are and how many are left-handed. So in our experiment, 18 out of 140 students are left-handed. Okay, so normally you would pick these hypotheses before you ran the experiment. I only wrote it above here because typically this stuff up here, that is what you're given in the question. And this is part of what you need to figure out, but usually you would be given this, have to figure out the null and alternative hypothesis, and then you would run the experiment and you would get this, use those numbers to generate your p-value. Okay, so the first thing we need to figure out are these null and alternative hypothesis, and then we're going to flip over to Minitab to run our experiment. So let's get Minitab open here. We'll do stat, basic statistics, one proportion. Some of these numbers are changing, right? For this experiment, it was 18 out of 140. And our null hypothesis number is 0.1, that's 10%. And we're sticking with not equals for our alternative hypothesis. You know, the default is not equals. If you're not sure what to use not equals. We're going to keep using not equals for our alternative hypothesis unless there's a very clear reason laid out in the situation from the word problem to suggest we should use something else. Okay, so we'll hit OK, see what we get. So it looks like in our sample, it was just under 13% that were left-handed. So that's more than 10%. But look at the p-value. It's 0.323. That's like 32%. So we're saying that if it's true that 10% of students are left-handed, there's a 32% chance that this experiment could happen, that as many as 13% in one particular class of 140 could be left-handed. So our p-value came out to 0.323. That is bigger than 5%. It's not small enough for us to say that it is too unusual. It's not a particularly small percentage. 0.323 is something that's going to come up all the time. Okay, so this is not a small p-value. We do not have evidence that the null hypothesis is wrong. So we do not have strong evidence that H0 is false. Okay, so does that mean that we've proved that 10% is the right number? Well, no, it might be 11%, it might be 9%, it might be 12%, we don't know. All we know is that like what just happened could have happened if it were 10%. So we have no reason to believe that that number is false. Maybe it's right, maybe it's wrong, we don't know. So we don't want to say we have strong evidence that the proper proportion is 10%, because we don't. All that a hypothesis test can do is take a null hypothesis and try to find evidence that it's wrong. It doesn't really provide any evidence that it's right. So either you show that it's wrong or you don't show that it's wrong. It's a very weird thing. Hypothesis test is a tough thing to wrap your mind around and get used to. So that's why we're going to crank out a few examples. I think that that's enough to say about this particular example. Yeah, so at the end, your conclusion is usually going to be if the p-value is small, as in smaller than the significance level, you say we have strong evidence that the null hypothesis is false, and instead the alternative hypothesis is true. If the p-value is not small, it's not smaller than the significance level, you say you don't have strong evidence that the null hypothesis is false. Doesn't mean the null hypothesis is for sure true. You just, it's kind of like an inconclusive result. Okay. End this video, move on to the next example.